Which of the following quantities remain constant in a uniform circular motion? In circular motion, the speed remains constant. For example, if you see this is a circular motion, then how we show it? The direction of motion will be this. So this is the direction of velocity. But if it is a uniform motion, its magnitude remains constant so that its speed remains constant, which we show with equal sized arrows. So velocity is changing, but the speed remains constant. The direction of motion in circular motion is along the tangent at that point of the circular path. Direction of motion is the direction of velocity. Let me draw it again. Let's say this is the circular motion we are having, and now a particle is moving like this, going in a circular path. Now if you want to know what is the speed here, so what we'll do, we'll draw a straight line tangent just touching to this point, to the path, circular path, and along that line, according to the rotation, let's say it is rotating like this, so our direction of motion or direction of velocity will be this. What about this point? Again, the tangent in the direction of the motion or rotation I have to take, because it is going this side. It will depend on this. If it is rotating like that, then we have to make arrow on the other side. But the important point is we have to first draw a tangent. So this is the tangent line, extended tangent line. Our direction of motion will be always along these line, and then we'll put according to how it is rotating, we'll put an arrow. So it is always along the tangent at that point on the circular path. The direction of the centripetal force is always towards the center. The centripetal, the word itself means towards center or center seeking. So in case we have a, in case we have, let's say, a string and a stone, we have tied it here and it is going around like this. So the force which we are applying through this string is centripetal force and will be always towards the center. That's why this force is responsible for this motion. So even in this case, let's say the stone has reached here, the direction of centripetal force will be in this direction, always towards the center. Centrifugal force, it is a fictitious force. It is not a real force. We only use it in case of non-inertial frames. Non-inertial frames, where frames are, the perspective is not stationary. We are also rotating, we can say, with the rotation. So for example, if this is circular motion is having, and it is a car, right, and this guy is going like this, and if you are sitting at the back, okay, here at the back you are sitting, you are also rotating with this. So your frame of reference is not an inertial frame, it is a non-inertial frame. In that case, we need to introduce the fictitious force to explain that why this box is not moving this side. It is having this force this side, right? So it should move this side. Why it's not moving? To explain to this guy who's rotating with it, which is who's having the non-inertial frame, we explain it by, because we have a fictitious force which is called a centrifugal force. So this we only use when we are, our frame of reference is non-inertial, or we are in rotating frame of reference. An artificial satellite is moving in a circular orbit around the Earth. Which statement is correct? So this straight away, this option D is correct. Centripetal force due to the Earth's gravity continuously changes the direction of a velocity. So it is the similar case of a string. When we were having a stone, tied to a string. So if we cut the string, this stone will shoot up. It will continue its motion due to law of inertia, law of motion this time. But now, because the string is there, it is keeping this stone in this path, in this circular path. Similar way, if we have a Earth now, and this is a satellite, and it is moving in a circular fashion, we don't have any string here, but this string is invisible, which is called gravitational force. Clothes in a dryer of a washing machine appears to stick to the drum walls during spinning. What provides the necessary centripetal force to keep the clothes moving in a circle? Very intuitive, drum walls. If walls are not there, why they will rotate? For example, this is the washing machine we are seeing, and the clothes are, they are just get onto the walls, and then due to these walls push them inside. If the walls will not give the reaction, let's say if it is broken, if there's a hole here, this clothes will just shoot out as the cut string, as we are cutting the string and imagining that a ball is moving outward, the same way it will happen in this case. So this force is now given by the reaction of drum walls. Now there are assertion and reasoning basic question. When a beam is in static equilibrium, the sum of clockwise movement is equal to the sum of anti-clockwise movement. That's correct. According to the principle of movements for a body in equilibrium, the sum of movements acting in one direction must be equal to the sum of movements in opposite direction. They both are saying the same thing, and they are both correct. So this will be our answer. The both A and R are true, and R is the correct explanation of A. Let's go to the question number 8. Let's read the assertion. A heavier object placed at a far distance from the pivot point will have the same moment as a lighter object placed close to the pivot point. This is wrong. Actually, reverse can be true. Like for example, this is a rod we are having, and here is a heavier box, and here is a lighter box. So if we have more distance of heavier, it will create huge movement here. But if we are keeping for the lighter object less, the movement will be also less for the lighter one. So they can't be equal. They cannot, be equal movements. So this is just a wrong case. Let's read the reason about it. The moment of force is determined by the magnitude, yes, of the force along with its perpendicular distance. Now there is one confusion that they have used this word along. Along mostly means in the same direction. So if it is that so, then both A and assertion and reasoning is wrong. But in textbook, you will see only they have said that assertion is wrong and this they have said correctly. So maybe they don't consider this word. So the moment of force is determined by the magnitude of the force with its perpendicular distance from the pivot point. Then the textbook answer will be correct. Let's go to the ninth assertion. The center of gravity of an irregularly shaped object always lies at its geometrical center. No, the center of gravity depends on the distribution of mass within an object. Yeah, it depends on the distribution of mass, but it cannot be surely for irregularly shaped. It will not be always at the geometrical center. So this assertion will be wrong, but this is correct because center of gravity, it depends on distribution of mass within an object. Like for example, if we say distribution of mass is like this, right? So you will say the center of gravity will be somewhere like this. What if I change the shape or distribution? Let's say I put all the heavy stuff this side, same shape, but now I'm putting more mass here, okay, and lighter mass here. So according to the distribution of mass, the COG will shift. Now COG can lie here because the heavier thing is on this side towards the left. So COG will shift towards the left. So it depends on the center of gravity, depends on the distribution of mass, but this statement is wrong.